It is so good to be here. Let's start with a little introduction. I like to introduce myself too, just to make sure that I say all those words too. My name's Nash. I am a developer evangelist at a company called Twilio. That's us over there in the red. Say that's us. There's no one sitting there at the table, but they're waving from the back. It's fine. Twilio, if you don't know, is a whole set of communications APIs that you can use in your applications to do anything from sending and receiving text messages or emails or WhatsApp messages, all the way through to making phone calls, making video chats, and sending two-factor authentication things. Anything communications that you could think of that you want to do in your application, we've probably got an API for you to do that with. I'm not obviously here to talk to you on this stage. Come and talk to us over there if you want to talk about that. Or if you have questions, burning questions afterwards, find me online. I'm Phil Nash pretty much everywhere. Or just drop me an email at philnash@twilio.com. Happy to chat anytime. And again, it is incredibly great to see you all in person. But what I really want to talk about today is video chats. Because, look, I think it's important, and I think the thing that we've realized over the last couple of years, that whilst it is in fact amazing to see people in person, you don't need to go in person to a whole bunch of things if you don't need to. And so what we ended up with a bit of our lives on the screen over the last couple of years. But we shouldn't be throwing that all away necessarily, because we can now meet again in person. And then of course I titled this "You're on Mute" because that's everyone's biggest complaint, everyone's biggest shout. You might be wondering, we're talking about WebRTC here. WebRTC is our inbuilt API on the web for real-time audio and video. And one of the first questions anyone will ask is like, why would we need this? We've got Zoom, we've got Teams, we've got Cisco WebEx, I guess. I've used it. There's somebody out there making me use it. And that's a reasonably good question. But what I think is important about this is that those applications, those apps that maybe we have downloaded, probably because our business made us, especially if it's WebEx, possibly if our business made us do it, is because that is great as a general, everyday, everybody has already agreed to talk on this one application kind of thing. It's great for work. It's great for, in the case where we were locked down, friends or family. And still, it's great in my case. I live in Australia, but I come from the UK. And so being able to chat to my family on a video chat when I want to, as long as it's not too early in the morning for them or late at night for me, is great. But those applications are not good for the world of, say, one-off applications. If you need to prove your identity to a bank that you're signing up to online, you can do that via a video chat, but you don't want to have to download Microsoft Teams to make that happen. If you can do that in the web browser, then that's brilliant. And if you don't have to go and visit a bank, brilliant. It's not so great for specialist applications either. If you're thinking of, I don't know, e-learning, learning online, remote learning, I think is a better way to put it, being able to build an experience that a teacher can control and use with students. The amount of customizability we have available to us on the web is so much more than just the generic buttons that something like Zoom or Teams gives us. Another example of this, and I think it's a particularly good one, is that there are developer recruitment tools out there that now have online interviewing as part of it, and built into that is an online pair programming situation. Now sure, in Zoom or one of the other applications, you can share your screen and show them what you're doing, but in an online, specially built interviewing application, you can both be in charge of that keyboard, as a pair programming kind of thing would be. So specialist applications like this would also be great. So WebRTC is for all those other applications outside of you're at work and you need to have a conference call, or you're with your family and you want to have a conference call. I don't know. WebRTC is for all those other things. I think it's just very exciting. And it actually moves beyond video chat as well. WebRTC allows us to have real-time video, audio, and data experiences. And one of the interesting parts about that is the data part. You don't have to make when you make a WebRTC application, it doesn't have to use video and audio. We can just do a real-time data thing. And that's quite cool as well. I'll get onto some of those bits in a bit. So today, as part of this talk, I'm going to give you a very quick overview of the basics of WebRTC and how things kind of hang together. And mainly I'm going to spend the time talking about controlling the user experience and the things that we have access to in the web platform that allow us to customize and control a WebRTC experience. Some of the fun kind of edge cases of it, and some of the more useful things. And then finally, just a couple of tools and takeaways that hopefully excite you about going to use WebRTC things in the future. So the basics of WebRTC, how does it all work? Well, these are my diagrams, my people that are going to get in a WebRTC chat. I have somebody on a laptop, somebody on a mobile device, somebody on a desktop PC. Ooh, yeah. And in the middle there's a server there. And what we need to do is connect these people together. Now, WebRTC is great because it's a peer-to-peer protocol. You can actually connect those peers, those people who want to connect directly to each other. But in order to do that, you kind of have to tell them that the other people are there. And for that, we need to do some signaling. We need to use a server to do our serverless thing. This is serverless not in the other people's servers thing. This is serverless that's in peer-to-peer. Anyway, you do need that server to start with. You need to be able to signal to say, hey, this person is here, this person's in this room, this person can be connected to. And once you've done that via the service, that's where you can then connect people directly. That signaling and the sort of discovery stage allows each peer in this network to generate for themselves kind of an IP address and port number on which their browser is available to receive incoming connections from other browsers who also implement WebRTC. And once they've shared those addresses, that's when you can connect directly. Now, this is great. It allows you to pick basically the closest possible, or the shortest possible path between those peers. And so it's really good for performance in small groups of people. However, when you get more than kind of 3 people in a peer-to-peer conversation using video, or more than about 10 using just audio, it can be really difficult on your devices, particularly the mobile device. And it's not necessarily a bandwidth problem, though it could be a bandwidth problem, but it's more likely to be a processing capability problem, especially on low-powered mobile devices. Being able to stream in audio and video from each other peer becomes harder and harder. So the second option for this is to use what's called an SFU, selective forwarding unit, at which point this becomes the peer to everybody else in the network, and receives all the streams and then streams back out to the other parties in the conversation. This can be a nice big beefy kind of media server and allows you to kind of boost the size of your rooms, boost the size of your video chats a bit more. So that's really useful. That's kind of how it all hangs together. I'm not going to kind of cover the APIs for this today because that's something I like to talk about, but it's not the fun part of this talk. So I'm going to run on through to talking about improving the user experience, because that I think is the important thing here. What we're trying to do when we build a WebRTC application is make a great user experience for the application, the thing we want to do. So we'll start with media. In terms of media, hopefully, has anybody played with kind of the Get User Media API before? Yeah, a couple, right? Yeah. This is how we get access to a camera and a microphone, the video and audio inputs from our users, and it's wonderful. You can use this. This doesn't need to be used in a video chat. This is the sort of stuff that you can use in order to maybe even just take a picture of somebody, like to make an avatar for them on an application. You get access to the audio and video inputs. You don't need audio for a picture, but you know what I mean. We get access to the audio and video inputs from the browser, from the device they're on. And this is kind of the simplest version of dealing with it, by just saying, yes, I would like audio and video. This, of course, being the browser, being the web, requires a couple of things. It requires you to be on HTTPS to ask for this. And funnily enough, this is one of those APIs that actually didn't originally require HTTPS, and that got changed as browsers went, no, this is a good thing. Making things happen on secure context is important. So you need to be on HTTPS, and then you still have to ask the permission of the user. And so our happy path here is you ask for permission, and we go straight to the promise resolving. But the sad path is we could catch a permissions error. And so it's always good when you're building anything that requires WebRTC like this, Get User Media like this, to make sure you handle permission failures, especially because sometimes people just fat finger the wrong button anyway and block access to the camera microphone. And so you need to be able to say, you can't join this call now because you turned your microphone and your camera off and you didn't let me have it. So that's good to do. Second up is just asking for, is this object in the middle bit here? This is actually a really interesting object, not this one, but the things you can put inside of it. Because here we're just saying, browser, give me whatever the default thing is for audio and video. But we can do better than that. If, for example, we wanted to build this thing, build a video chat that's going to work on a mobile device, we probably want to describe which video, which camera we want, because this one's got, well, that only counts as one, I think. But also the one on the front, we've got a forward and back-facing camera. We can't necessarily know that, but what we can do is give the browser hints to say, this is the kind of stuff we want. And so you can start passing options instead of just a Boolean true here. And in this case, like getting that front-facing camera on a mobile device, if you ask for the facing mode of user, that tends to give you that camera that is facing the user on the front side of the device. You can give it other options as well. What I think is funny about this is two of them are completely useless. The other options are environment, which is the back-facing camera on the back of the device, and left and right, which like one on the left and one on the, I don't know. I've never seen that work. I have no idea what that means. So environment and user are the facing modes that you might well care about. So in this case, if you're building like a camera application where you want to be using that back camera, ask for the facing mode of environment. That's useful. Sometimes you want to ask for an exact device, though, which you can do. If you have the ID of a camera that is linked to the system, you can say, hey, I would like the exact device ID that happens here. You can't just make this ID up. If you ask for an exact ID that does not exist, this will fail. This will fail immediately with this will throw an error. So we can find those IDs of the devices by calling on enumerate devices API, which runs off of media devices the same as getUserMedia does. And this allows us to kind of list out the available devices, both video and audio, and then kind of, in this particular example code, just log them, but we can put them in a drop-down menu for selecting from. Now, it's important to know at this point that some browsers are very privacy conscious. They don't like people to be able to fingerprint devices, browsers, and kind of giving all the names of your devices is a real clear fingerprint of who you are. So in browsers like Firefox and Safari, when you call enumerate devices before you've accessed the camera in the first place, so before you've done the permissions for just a regular getUserMedia, these do not come back with labels. They come back with nothing. They won't the device is there. We'll tell you nothing about it. And once you've got permission to see the devices, that's when you can. That's when you get the actual labels from them. Right, that's what I'm saying there. You don't necessarily. The dies.label may well be blank until you've asked for permission. Once you've got that list, you can then. The device has an ID in it as well, and that's where you use it in that. In the device ID exact constraint. Other media constraints you can use is resolution. Most browsers, when you ask for the, at least on desktop, when you ask the browser for the video input, it tends to come at 640 by 480 resolution, and those cameras can do better than that. And the cameras on devices can definitely do better than that. And so it's good to actually ask for something that's better than that. Weirdly enough, of course, asking for a width of 1920 and a height of 1080, asking for 1080p resolution is sort of still asking the browser to hopefully give you that. You might not get it, but it's a hint. You can do better hints, though, saying that you'd be happy to take a resolution between a minimum of 320 and a max of 920, where the ideal is 920. We want the 1920, sorry. We want the biggest thing we can have. And giving that kind of things gives the browser the most opportunity to serve that to you. A bad idea is to ask for exact resolutions, because if the browser cannot give that to you, it will fail with an over-constrained error. And that's not that much fun, so don't recommend that. And you can't know ahead of time what the browser and what the device resolution could be. So this kind of, give me a range, and here's ideally what I'd like, is probably the best way to deal with this. Media constraints then get weird. My favorite part of this, there are some advanced video constraints where you can pass an array of objects, and they are very, very like browser specific, but you can turn the torch on using this. And I do actually have a little example here. Oh god, there's all my background things. Anyway, let's see this. This only works Chrome on an Android device, and if I just run this right now, I can get hold of the camera. I've asked for the environment device there, and then we've got a little toggle torch button at the top there, which works, right? That's cool. Can't turn it off again though. It doesn't work. There is no way. Like I don't. It's not toggle. It does not toggle at all. The only way to turn it off in this particular case is to refresh the browser in this app, or indeed to turn off the video stream itself. See, the torch in this case is actually linked to the video stream, and that's why it's not really a torch, but it's actually giving you light for your video, I guess. I can see use cases for this being like if you're building a barcode scanner using Get User Media, and you want people to be able to scan barcodes in the dark. And then once you've scanned the barcode, you can turn off the video stream, which does turn off the torch with it. But I don't know. I kind of wish we just had a media devices torch toggle function or something, because, why wouldn't we want to play with the torch in the browser? It's quite fun. When you're working with these media constraints, if you've already gone through Get User Media and you've got access to your camera, your microphone, and you want to change the constraints on it, when you realize that you've asked for 480 by 640, 640 by 480, and you really wanted 1080p, you can actually pass the constraints back through using apply constraints as a method on the track object itself. This is really useful to be able to change that, and particularly like if you're working inside a video app itself and you find that the network is degraded, then getting a smaller video would be a good thing, or if it turns out the network has recovered, you can go back to that full high definition kind of resolution. This is a really useful thing to do. One important thing to do there is not try and apply constraints and give the video track a new ID. That doesn't make any sense. If you're trying to say, this video track now needs to come from this other camera, it doesn't like that. So instead, if you're going to change cameras, the best plan is to stop the first one and then ask for permission for the next one. It's particularly important on iOS devices to stop the first one, because iOS is very much not interested in you having access to both cameras at the same time. And if you try and ask for permission to look at a new camera without stopping the previous one, it won't let you. Other devices will, but in general, if you're building for all devices, then iOS will want you to stop the video track first. Fun times. So I have a bit of a demo that's a little more useful than the torch, I think. So this is just a thing where I'm asking for different constraints and different use cases. And so in this particular case, in this browser, I've actually given permission to get access to my cameras beforehand. You can see I've got 3 cameras. I don't. 2 of them are virtual and don't actually show you anything, but I'll turn on the real camera for now. And if we ask for that, I'm asking for it in 720p, and Chrome in this particular case is happy to give it to me in 720p. That's nice. Hello. I just like getting my face on screen more times during a talk than necessary. I can go and ask for it in a smaller 640 by 480 and go get access to that, and that'll actually move it into like 4.3 version as well. Which I think is cool. It's useful. We can also ask for other cameras, and this is where I'm going to stop the track and ask for the new track. And this is a virtual camera that doesn't exist, so it's not very useful. But it at least shows that we can change camera successfully. And the final thing is 1920 by 1080. I think Chrome is happy to give that to me normally. No, I see. In this particular case, I asked for 1920 by 1080, and Chrome went, but your camera only does 720, so that's all you can have. Thanks, I guess. But this is done using those kind of ideal constraints as well. Like it can be between things, but like the browser is going to do its best effort unless you specify exact, and then it will fail if it can't do it, and that's fine. So cool. Being able to apply different media constraints to the things we have access to is really useful. So recommendations here when you're building something like this is always to provide a way to check and change those inputs. Super important because sometimes people have loads of cameras. I know everybody I know has like now got several different fancier cameras attached to their home setup at least, so that when they're doing their Zoom calls they look a bit fancier because the FaceTime camera on one of these at least is rubbish, as we've just shown on screen. So allow people to check and change those inputs. Chrome always, with me as well, like changes its defaults all the time. Earlier today it was defaulting to just the wrong microphone. Again, a virtual microphone. I've only got one microphone on here, so it was just always silent. Brilliant. And the other one is just understand those available media constraints. There are many, many more media constraints, and you can query your browser to say which constraints are actually available, so you don't turn the torch toggle button on for devices that can't do that. And you get rid of the torch toggle off button, it just doesn't exist. It's fine. Second up is screen share. Now, I've been working with video and WebRTC on the web for sort of since about 2015. I'm a massive fan of it. I say that. I actually, the first time that any browser implemented Get User Media was the Opera browser back in the day. And I was so excited by it, I downloaded their sort of experimental branch version so I could be like, oh my god, me on a camera on my own browser. It was cool. So maybe I've been working with this since 2012, really. But for much of that time, screen sharing, which of course is super useful in any kind of video chat, when you want to show somebody something you're actually working on or something you need support with, something you need help with, screen sharing is great. You used to have to do this via a browser plugin. It was a pain. You had to build your own browser plugin, and that's not the web experience that we ever want. The web experience is give somebody a URL, and they can experience the app as intended. And so having to include an extension as part of that, it's a bad idea. Ultimately, there was a point where the Chrome browser decided they were kicking out this a form of installing extensions that only required sort of a one-click thing, which was kind of useful for people doing screen sharing. And then they said they were going to stop that. And that sped up the rest of the browsers to implement the actual screen share API, which looks like this. Also lives on the media devices object. And is simple as calling get display media, which pops up the permissions to say which screen or which tab or which browser would you like to share. And once somebody agrees to share it, you get another video stream, much like the camera stream. This doesn't work on mobile devices. They don't tend to like screen sharing for some reason. But on desktop devices it does. And I think it's very cool. I'm just going to show you that working right now. I have a little video application that I've been working on. It's my own personal Zoom. And this is another example of that kind of give people access to their media before they jump into a call so they can change stuff. I'm also going to talk a bit about the microphone stuff there, but like being able to change these things to a virtual microphone that makes no sound at all is just useful. Let's dive into there. I'm going to join a room. The room is called CityJS. And inside this application, there's me again, hello. I can share screen, and that's just going to call and get display media, giving us access to, I only have one screen to share right now, but I could choose a different window. I've only got one window open. Or a different Chrome tab. So you just share a tab. That's quite cool. I'm going to share the whole screen for now, because then we get the infinity screens off into the background. Bit of fun there. So you get access to that stream. You can also listen to the video track that this has. So I can either stop it sharing by clicking on my stop sharing button down here, or you can listen to the browser it stopped and handle that. Really useful. Yeah, sharing screens, it's cool. And of course, you can combine this kind of thing with something like the Media Recorder API if you wanted to build a browser-based application that could do just like little screen videos or something. Brilliant. You can build Loom browser. I don't know if anybody likes Loom. I don't. Some people like it. So the recommendation there is just like, we've got this in the platform. The platform is giving us so much. Extensions are terrible. There was a funny point when Firefox actually had implemented an API like this for screen sharing, but it was whitelisted, so you had to be on their friends list in order to screen share. But now it is available for everybody, and it has been for a few years now, so it's good stuff. Next up is the Web Audio API. Web Audio API is one of my favorite things on the web. We've seen a bit of like creating audio with the Web Audio API today, and that sort of makes me very excited. In this particular case, I think we should use it for the other side of things that you can do with Web Audio, which is to process the audio and know what's going on. And so Web Audio API is not part of WebRTC. I just think it's an important part of like displaying audio to the user and then doing other things based on audio like that. And so if I go back to the demo, that's kind of where I am here. This is just a visualization to show that basically the microphone is working before you try and jump into a call. I think that's great. And it does obviously show that if for example, Chrome was still picking a virtual device for me, that there's obviously something wrong there. And that if I join the call, I will not be heard. And I'll have a bunch of people screaming, "You're on mute" at me. So that's cool. But that also becomes the next part of it. Like, how do we beat that problem? How do we beat the "you're on mute" section? Because even if somebody has picked the right microphone and then muted themselves because they're in a big call together, we are 2.5 years since everybody had to learn how to use these applications, yet still people will start. And everybody else in the call, you're in a call with 50 people and nobody wants to press their mute button to say, "You're on mute," and then 3 people do it at the same time, nobody knows what's going on. So can we handle that in the browser using the Web Audio API? Yes, we can. And so I did an implementation of it. And what it basically does is take, that is just a visualization of the different kind of slices of If I now try and talk, it's going to say something like, "Are you talking? You said you're on mute." The browser shouts, "Are you on mute?" at you. Still making noise at it. Yeah, okay. We'll unmute for now. I'll disconnect from there. So we can do that, and it's I think that's 20 lines of code. It was like 10 lines of code after I did build the volume visualizer. And so it's super simple to do. The browser gives us so many APIs to do this with. It's wonderful. Now, I just want to close with a couple of useful tools if you do go about building something like this, tools that are going to help you build some of these recommendations that I've mentioned. And I say tools, I think there's just one tool. Twilio has, we obviously make a video product which you can use to do the kind of back end of this stuff a lot easier. But we've also provided an open source diagnostics library which allows you to much easier build out those tests, testing both the capable bitrate of the browser, the input audio, and output video as well. And so I can show you, I just kind of implemented it in a very basic way. Like the API itself, the library itself gives you a bunch of simple APIs to do this. And so I can start, say, a bitrate test, which is actually going to connect to a WebRTC peer and sort of check the currently available bitrate as it kind of ramps up. There we go, that's not bad. 16,020K, that's all right. I'll stop that for now. It gives you the average over the time and the measurements. It gives you a volume meter for an audio input test, so that can be visualized as volume, cool, and tells you like what the volume was over that time. You can test audio output, which is also useful to know that somebody can hear that as well. Something I don't even cover in my thing. And then testing the video and kind of reading the basic resolution that you're getting from a video. But that's relatively straightforward. So that is a free open source library that you can go and use and explore under Twilio's RTC diagnostics. Really very useful. So that's kind of it. We've spent a lot of time on screen over the last couple of years. For WebRTC, so you can play from across the room. Amazing stuff. I love using a little app called Snapdrop, which is like Apple's AirDrop, but just across browsers. If you're on the same network and open Snapdrop in 2 different applications, you can just pass files back and forth between them. Really cool. It's just data-based. There have been applications, some of it's 100% better to have people real in person in a room together, but the best meetup online I ever went to over the course of the pandemic included a little virtual world where we all got to choose little characters and run around in sort of 2-3 dimensions, and using spatial audio allowed you to sort of join conversations by sidling up to them, which looked cuter when it's a little animal that you were playing as, and have conversations elsewhere, because the audio would kind of fade in and out depending on how close you got to people. Because if you're on any regular video call, the loudest person talks longest and loudest, and you can only have one conversation, so spatial audio allows you to do more than one at a time. So WebRTC is everywhere because it's in browsers, it's on our devices, it's in our pocket. This is a tool that the browser gives us to build these experiences. It's powerful because it's on the web, and every one of these things can live behind a URL. It can be a one-off experience, or it could be something you use daily, but not having to download another app and sign up for another service is powerful and possible because we're on the web. And we have, as developers, the tools to build great WebRTC experiences. We have the tools in the platform, and there are plenty of open source libraries as well that can be used and relied upon to do this. So that's all I've got for you today. Again, my name's Phil Nash. I'm a developer evangelist at Twilio. I'd love to talk to you about the exciting kind of real-time things we could build using this, or if you just want to talk about Twilio stuff, I'm also over there for that. We still have some socks available. Thank you very much.
Any questions for Phil? Any questions from the audience? If not, you can find Phil. I think Phil will be over there.
You're right there.
In the Twilio booth. But thank you so much, Phil.
So thank you. Get out your way.